What's up, everyone? This is lab 3. It's black hole. And so everything in this lab was computational. And the first part of the lab was determining the mass of a black hole using Newton's second law and stuff related to that. And the second part of the lab was seeing what initial velocity a spaceship needs to escape the event horizon of a black hole. And everything was done in GlowScript. Here's some of the physics. I think these are all the physics concepts used in this lab. The force of gravity between two objects, Newton's second law, velocity update formula, position update formula with non-constant force, and then F net is equal to F net parallel plus F net perpendicular. And so since most of the stuff was, or all of the lab was done in code, I'm just gonna take you to the code. And so basically I don't know what it really does, we didn't have to touch it. Alright, so what I did was here. So I inputted the mass of the star, and then the change in time, which was a day in seconds. And then here's the calculation, how we would calculate it. F net, or V initial, V final, use this. I didn't actually do that. It came with the code. But basically we used the V initial, V final to solve for P initial and P final, and that's just momentum initial, momentum final. And we use that to solve for delta P, change in momentum, change in velocity. And then so dp dt is equal to delta P over delta T, and dp dt is just the net force. And we know that from Newton's second law, F is equal to dp dt. And so yeah, to break it down into the parallel and perpendicular components, you do P hat is equal to P initial divided by the magnitude of P initial. And then you do that, and then you do the magnitude of, so this is just the change in magnitude of momentum, divide that by time, and then you get the parallel component is this times P hat, so the direction. And then so yeah, F net parallel is equal to that. And then what you can do is you can say F net is equal to F net parallel plus F net perp, so the perpendicular force is equal to F net minus F net parallel. And so you can get those two. And then this is the calculation for the black hole, the mass of the black hole, and it's just using this formula again, where big M is the mass of the black hole, and then you just do some basic arithmetic and solve for that. And so by running this, you get a simulation of how the motion of it, and then a bunch of the masses. And so because there's a little bit of variation, I just put all the data into a spreadsheet and then averaged it, and I got this for the mass of my black hole, which I inputted into the second part of the lab, which was velocity a ship needed to escape the event horizon. So basically, where did I put it? Oh yeah, mass of the black hole, put that here. This stuff already was put in. And basically we need to solve for the initial ship speed of x and y. And honestly, I didn't actually have a formula to solve it out. I just kind of guessed and checked. I knew it had to be less than the speed of light because, nothing can be beyond the speed of light. It had to be greater than the speed of the planet. So just did some numbers in between there. For this, we're calculating this is just calculating the motion of the of the ship. And so yeah, this is using the same formula as here to solve for the force on the planet, yada 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 yada. And then you finally use all of that, the force that you saw from above, with the position update formula and the velocity update formula to show the position of the ship and the planet. And so this is what it looks like. Yeah, so it's pretty cool. It pretty much does that. Possible errors. I might have messed up some of the formulas, but the code still runs, so it would run, but it wouldn't be correct, if you know what I'm saying. And then I could have just messed up some numbers as well. And then net force is always the same, but the rate change momentum determines the direction of the movement of the object. FNAP changes direction of motion, and FNAP parallel changes speed. And the what if, to be honest, I was running out of time, so I couldn't really figure this out, but I just assumed that motion should always be parallel to n hat. So like the velocity that makes it so that the momentum is parallel to n hat. Otherwise, the ship will get sucked in. Thank you for listening to my lab.